Hello students, my name is Atulya Kumar, Assistant Professor BUD ITM Lucknow. In this lecture series, we are studying about Introduction to Solid Mechanics. In today's lecture, we will study about theory of failure. So, the contents of today's lectures are: we have to study this five types of theory of failure. The first one, theory of failure, we have briefly discussed about each and every type of theory of failure in our previous classes, but in this class we will discuss a detailed analysis of each and every theory failure. The first will be a study about maximum principal stress theory failure, also known as Rankine theory failure. Second one is maximum principal strain failure or theory, also known as Saint Venant theory. Maximum shear stress failure theory, also known as Guest theory. Maximum strain energy theory, also known as Hague theory, and maximum shear strain energy theory, also known as Mises and Henke theory. Okay, so let's start. So first theory that we will study is maximum principal stress theory, which was first coined by Rankine. In this theory, basically we are equating two stresses, one at the ultimate level when our stress is going to be failed. So basically what this theory state, according to this theory, the failure will occur when the maximum principal tensile stress in a complex system reaches the maximum value of stress at elastic limit in simple tension, or minimum principal of stresses reaches the elastic limit in compression. So basically what is this simple condition and complex condition? Simple condition means that there either will be only shear stress available or only axial stress available. There is no other stress available on acting on a body. But complex stress system, there may be two dimensional stress is acting on a body, or three dimensional state of state is acting on a body. For example, let us see suppose this is our body and this is a body, and ABCD, this body is subjected to only one stress. Or suppose let us say this is the axis. This is the axis of this body. This is the axis of body, and body subjected to only one kind of stress. This is this stress. So this stress is axial stress, and this stress is acting only in one condition, only in one direction. But the effect of this stress may happen in other directions also, as we have studied that we have coined a term known as Poisson ratio from this stress condition, that what will be the impact of this stress, in perpendicular direction or other perpendicular direction. So maximum principal theory state that the maximum principal stress of a complex system at the time of failure should be equal to the maximum stress at elastic limit in a simple tension. So this is this is simple tension, because tensile force is acting on a body, only one state of stress. What is complex system? The complex system is like this. Suppose this is our body, and this body is subjected to two types of stress, sigma 1, sigma 2, and this is sigma 2. This body is subjected to two types of stress. Hence this the kind of body is said to be complex state of stress, because suppose we are observing this plane, this particular plane, we are observing this plane. At this plane, when we focus, first the deflection or deformation observed due to stress applied on this plane, that is sigma 2. Second, we cannot ignore the amount of stress applied on perpendicular plane. Okay. So basically if we have to study the total deformation on this plane is equal to, we can say that sigma 2 upon E plus minus mu times of sigma 1 upon E. Okay. As we have studied this concept in initial lecture. So this is the total deformation observed in body, in which the sigma 2 upon E is given deformation due to stress acting on that particular plane. Sigma 1 upon E is giving the deformation by the stress acting on a perpendicular plane. So basically what is new? New is a Poisson ratio, that it's just convert a state of stress, convert the state of deformation while acting on a perpendicular direction. Okay. So according to Rankine theory, that whatever the complex state of a stress situation, but but at the time of failure the value of maximum principal stress acting in a complex state of system should be equal to or reaches the value of maximum stress at the elastic limit, okay. So this one value, this sigma 1 must be equal to this value sigma at the time of failure, because we are assuming that sigma 1 is greater than sigma 2, it means sigma 1 is maximum principal stress, sigma 1 is maximum principal stress, sigma 2 is minimum principal stress, okay. So at the time of failure, this value of sigma 1 is equal to, this value of sigma 1 is approximately equal to, or we can say greater than equal to sigma at the time of failure, okay. This was the one part of definition or one part of theory. The another part is that the minimum principal stress or minor principal stress, it should be equal to that maximum principal compressive stress under elastic condition. It means sigma 2 value should be equal to greater than sigma upon E into C. What is sigma EC? Sigma EC denoting elastic stress of body in compression, compression. What does this mean? This means that, okay, if we are expanding this part of legs, if we are expanding this part of body, okay. So other portion, and it means a DC plane or AB plane will get compressed, a DC plane or AB plane get compressed. It means at AC and DB plane, the compressive stress is acting. If we are applying sigma, it means a tensile stress at BC plane and AD plane. If we are applying tensile stress as AD and BC plane, but if we observe the amount of deformation in CD and AB plane, the amount of deformation that we are going to observe, is compressive, because this portion, the AD and BC plane is expanding due to tensile stress, but the perpendicular plane is getting compressed due to action of compressive stress. Hence the sigma 2 is compared with sigma 2 as minor principal stress gets compared to compressive stress at elastic limit, okay. So this was the Rankine theory. Basically Rankine theory state, in a simple term, if you have to explain the Rankine theory is saying that whatever the condition, whatever the state of stress you are acting on a body, just you have to focus the state at elastic limit, either it will be axial or it will be tensile or it will be compressive, but we have to focus on the state of stress on axial condition or at elastic limit condition. So this was the theory. Again, other statement of Rankine theory, that was application of Rankine theory is given, that if the maximum principal stress is the design criteria, if we are designing our structure or our body with the condition of maximum principal stress, then the maximum principal stress must not exceed the working stress of the material to be safe. Once again I am repeating the statement, according to this theory, if we are designing our body with respect to maximum principal stress, then at any point or during any loading period, the amount of stress should not exceed, the amount of stress developed in a body should not exceed the principal stress. What does it mean? It simply means to save our body from failure, sigma AT must not exceed the value of sigma 1. This was the design criteria. What is sigma AT? Sigma AT, we can say that elastic stress has elastic limit or working stress. What is sigma 1? Sigma 1 is the maximum principal stress. Other statement that was given in this theory basically ignore the other effect of other principal stresses and sharing stress on the other plane. We have to focus, either we are focusing on maximum principal stress or we are comparing with minor principal stress. We are not simultaneously taking both major principal stress, minor principal stress or shear stress. It is focusing only on one type of principal stresses and completely ignore other effect of other stresses acting on a body, due to which the brittle material do not fail by yielding but fail by brittle fracture. according to this theory, that brittle material which do not fail by yielding but fail by brittle fracture, the maximum principal stress theory gives considerable amount of reason for this theory. For this explanation, the maximum theory is suitably applied to this theory, that brittle material does not fail by yielding but failed by due to brittle fracture or sudden failure. So, this theory completely confirm this statement. Okay. Now, next theory is maximum principal strain theory. According to this theory states that the failure of a material occurs when the principal tensile strain in the material reaches the strain at the elastic limit in simple tension, or when the minimum principal strain reaches the elastic limit strain in a simple compression. Okay. So, first part of a statement is that the principal tensile strain in a material reaches the strain at elastic limit in simple tension. This was the first part of a statement, similar to the maximum stress theory. In stress theory, we have to just consider, we are considering in the place of strain we are considering the stress, but in this strain theory, the maximum principal tensile strain in a material reaches the strain at the elastic limit, or when the minimum tensile principal strain, or when the minimum principal or minor principal strain reaches the elastic limit strain in simple compression. Okay. This was the two condition that define the failure of a material under the maximum principal strain theory. So, what is principal strain theory? Principal strain theory is saying that the body will fail only when the major principal strain of a body reaches the value of elastic strain in simple tension, or the minor principal strain of a body reaches the value of elastic strain in simple compression. Okay. So, what is the value of strain? What is the value of strain in the direction of sigma 1? So, suppose we are taking this body, suppose we are taking 3D body, we are taking a 3D body, this is the 3D body. Okay. This is the sigma 1 plane, this is the sigma 2, and this outside body is acting under sigma 3 stress. This is the sigma 3 stress. So, if we have to find the amount of elastic strain, in the direction of sigma 1, then the elastic strain can be given as 1 by E into sigma 1 minus 1 by M into sigma 2 plus sigma 3. Basically, 1 by M can easily be written as Poisson ratio. So, elastic strain is equal to 1 by E into sigma 1 minus mu into sigma 2 plus sigma 3, mu sigma 2 upon sigma 3. Okay. So, we have already discussed this formula. Okay. What is the value of principal strain in the direction of sigma 3? Same, sigma 3 will be without any Poisson ratio, but when we have to use sigma, we have to calculate the amount of strain from sigma 2 or sigma 1 direction and multiplying it with the Poisson ratio to get the accurate result. So, E3 equal to 1 by E sigma 3 minus 1 by mu into sigma 2 plus sigma 1. Now, the condition of failure occurs according to this theory when this amount of strain, so E1 is the major principal strain, E1 is the major principal strain. So, for the major principal strain, condition is that strain should be equal to, at the time of failure, strain should be equal to strain at elastic limit under tensile condition. It means that this amount of strain get exceeded at this value of strain. And what is this value? Strain, according to Hooke's law, strain is directly strain should be equal to sigma upon E, stress upon A, modulus plasticity. So, we are just using simple formula. So, E1 exceeds sigma 80 upon E. It means at the time of failure, this condition will be happen. Similarly, for the minor principal strain, this is the minor principal strain, E3 is the minor principal strain. For the minor principal strain, we have to take the value of stress for simple compression at elastic limit. It means E3 value exceeded sigma EC upon E, So, for safety, if we have to prevent the failure, then from this equation should easily be coined as, or easily be modified as E1 equal to, E1 should be less than sigma 80 upon E. E1 should be less than sigma 80. What is the value of E1? E1 is equal to 1 by E into sigma 1 minus mu times of sigma 2 plus sigma 3, and it should be less than equal to what? Sigma 80 upon E. What is sigma 80 upon E? Sigma 80 is the amount of stress in simple tension at elastic limit. Okay. So, sigma 80. So, this get cancel out. So, sigma 1 minus mu times of sigma 2 plus sigma 3. So, it should be less than equal to sigma 80. It should be less than equal to sigma 80. Okay. This value should be less than equal to this. This is the condition for safety condition. For safety point of view. Similarly, for minor principal stress, this value should be converted as sigma 3 minus sigma 2 minus mu into sigma 2 into sigma 1. This is value equal to sigma EC. Just convert the same condition is same. Just convert the value of stresses at the suitable location. And what is the condition for design purpose? When we have to design a structure, we have to equate this value. For design purpose, we have to equate this value. With the amount of stresses or critical amount of stresses. From here, we can easily, like we should know about factor of safety. What is the factor of safety? Factor of safety is the ultimate strength. Factor of safety is the ratio of ultimate strength to working strength or working stress. This is the factor of safety. For body to be safe, the factor of safety should always be greater than equal to 1. Body will fail when factor of safety is less than equal to 1. Body will remain safe under any type of stress condition or any types of loading condition if the factor of safety is greater than 1. Body will fail if the factor of safety is less than 1. So, what is the ultimate strength? Of a body under maximum principal strength theory? The ultimate strength of a body is sigma 80. And what is the amount of working strength of a body? This is the amount of working strength of a body. Okay. Now, the next type of theory that we have to study is the maximum shear stress theory. We have studied about axial theory. Basically, the maximum principal strength, maximum strain theory and maximum stress theory both are axial stress theory. We are only talking about axial stresses at elastic limit, either in tension or in compression. But body will be also be subjected to shear stress, na? Body will be also subjected to shear stress, no? Hence, we have to check the safety from shear stress point of view. So, maximum shear stress theory states that according to this theory, the failure will occur when the maximum shear stress tau max in a complex system reaches the value of shear stress in simple tension at the elastic limit. Same condition, every condition is same, but we have just changed the state of stress. Till now we are studying about axial stress, but for body to be safe in shear stress, the maximum shear stress of a complex system, at the time of failure should be equal to the amount of shear stress developed at the elastic limit. Under the simple tension load. So, what is the value of maximum shear stress? We have studied in conversion of principal stress and principal strain that the maximum shear stress is given as tau max equal to sigma 1 minus sigma 3 by 2. Tau max is equal to sigma 1 minus sigma 3 by 2. Hence, this amount of shear stresses at the time of failure should be equal to amount of shear stresses at the elastic limit under simple tension. So, from that, the maximum amount of shear stresses at elastic limit in simple tension is given as sigma Et upon 2. Sigma E into sigma Et upon 2. Okay. So, this value should be equal to this value. In actual design, we have to replace sigma Et by safe stress. In actual design, we have to replace sigma Et upon with actual stresses. This theory is most suitable for ductile material, because ductile materials are basically yielding material. They will go under a long amount of deformation before failure. So, this theory is suitable for ductile failure. Maximum stress theory was suitable for brittle nature of failure, but maximum shear stress theory is suitable for ductile nature of failure. This theory does not give this accurate result for state under pure shear. For pure shear condition, this theory does not give accurate result, because under the pure shear stress condition, there is absence of axial load, any type of axial load, maybe on a perpendicular on any of the plane, there is the absence of axial load. Body is only subjected to shear stress. But but here we are using sigma 1 minus sigma 3 by 2, sigma 1 minus sigma 3. We have body must be under some kind of axial stresses or some kind of normal stresses, but in pure shear condition, body is not subjected to any kind of normal stresses, body is only under the influence of shear stresses. Hence, this theory does not give the accurate result for pure shear condition. This theory, this theory is also not suitable for the state of triaxial stress. For 3D condition also, we cannot use this amount of shear stress. But if in any of 3 conditions, the amount of shear stress is in any of 3 in one of the 3 axis or in 3 direction, the amount of shear stress or state of stress is equal to 0, then we can easily use this condition, maximum shear stress theory, for triaxial state of stress, because in triaxial stress we have 3 type of stress, sigma 1, sigma 2 and sigma 3. They are basically 3 type of stress, but in formula they are mentioning only sigma 1 and sigma 3. I am only major and minor principal stresses. There is absence of intermediate state of stress. There is absence of intermediate state of stress. Hence, that's why this value, this theory cannot be applied accurately for triaxial state of stress or for pure shear condition. Next type of stress is maximum strain energy theory. Next type of stress is maximum strain energy theory. What is the maximum strain energy? Maximum strain energy means according to this theory, the failure of a material occur when the total strain energy in the material reaches the total strain energy of material at the elastic limit in simple tension. Once again, first of all we have to discuss what is the strain energy. The strain energy, the amount of energy a body absorbed, when it is deformed. When it is deformed, that amount of energy is known as strain energy, as the name suggests itself. So, what is maximum strain theory? According to this theory, it states that the failure of a material occurs only when the total strain energy in a material reaches the total strain energy of the material at the elastic limit in simple tension. Okay. So, in simple word, if a body in a complex state of system is strain energy is equal to x, but for the same body to be safe, become safe, the amount of strain energy developed at axial tension must be less than x, so body to be safe. So, what is the value of strain energy in a complex state of system or 3D system? The amount of strain energy is given as u equal to 1 by 2e sigma 1 square plus sigma 2 square plus sigma 3 square minus 2u into sigma 1 plus sigma 2 plus sigma 3 into sigma 2 plus sigma 1 into sigma 3. This is the amount of strain energy given for the 3D system of body. At the time of failure, this amount of stress must be less than a strain energy of a material at the elastic limit. At the time of failure, this value should be equal to, but for the safety point of view, this value should be less than equal to sigma square upon 2e. But at the time of failure, this is equal to this amount of body. What is sigma E square upon 2e? Sigma E square 2e is the total strain energy of the material at the elastic limit under the simple tension condition. Okay, but for actual condition, we have to replace sigma E with working stress or working load. Okay. Next type of theory is maximum shear strain energy theory. According to this theory, the elastic failure occurs when the shear strain energy per unit volume in the stress material reaches a value equal to the shear strain energy per unit volume at the elastic limit point in a simple tension. So, amount of shear strain developed in a body for a complex state of stress system should be equal to the amount of shear strain energy developed at the elastic limit under the simple tension. This is the value. So, for shear strain energy calculation, the value is formula is u equal to 1 by 12 c sigma 1 minus sigma 2 square, sigma 2 minus sigma 3 square and sigma 3 minus sigma 1 square. This is the amount of value. To calculate the shear strain energy, for simple tension, we just have to replace sigma 2 equal to 0 or sigma 3 equal to 0, because as we know, the simple tension, there is only one kind of stress is acting. There is absence of other two stresses. Sigma 2 and sigma 3 is absent for a simple state of condition. Hence, we replace sigma 2 and sigma 3 equal to 0, and then we calculate this formula. For safety point of view, or let us say at the time of failure, u should be equal to u dash. u should be equal to u dash, u should be equal to u dash at the time of failure, at the time of failure, at the time of failure. But for safety point of view, u should be less than equal to u dash, u should be less than equal to u dash. Okay, thank you.